Have you ever wondered what the gelatin you enjoy in desserts, sweets, or even some medicines is actually made of? At first glance, it seems like a simple, colorful, and even magical food due to its vibrant texture, but behind each serving lies a complex industrial process that combines science, engineering, and strict quality controls. Hundreds of thousands of tons of gelatin are produced worldwide each year, and what begins as animal bones, skin, and cartilage ends up transformed into millions of sweet and enticing portions ready to arrive in supermarkets, hospitals, and schools. Before diving into the technical details, it's worth remembering that gelatin is not a recent invention. For centuries, different cultures learned that boiling animal bones and skins released a gelatinous substance that was used to thicken broths and prepare preserves. In the Middle Ages, European kitchens were already making thick broths that solidified when cooled thanks to collagen. However, producing gelatin by hand was a slow, expensive, and inaccessible process. It wasn't until the mid-19th century, with the development of more efficient extraction techniques, that gelatin began to be industrialized. At the beginning of the 20th century, companies in the United States and Europe perfected chemical and mechanical processes that made it possible to obtain the pure, transparent, flavored, and colorful gelatin we know today. Over time, gelatin became not only a popular dessert, but also a fundamental ingredient for the pharmaceutical industry, capsules and coatings, the food industry, gummy candies, yogurts, pâtés, and even the photography industry, gelatin-coated films. The gelatin journey begins in certified slaughterhouses and meat processors. Here, tons of animals destined primarily for human consumption are slaughtered every day. The most valuable cuts, such as loins, steaks, ribs, and sirloins, are separated with surgical precision and sent directly to market. What's left are the so-called meat byproducts: bones, tendons, skin, and cartilage. For most people, these remains would be considered waste. However, they contain one of the most abundant and useful proteins in the animal kingdom: collagen. Collagen is a structural protein that functions as a scaffold in connective tissues. Its unique feature is that, when subjected to heat and chemical processes, it breaks down into smaller fragments that gel. This means they can form a firm, elastic, and translucent substance: gelatin. These animal remains are collected, loaded into refrigerated trucks, and sent to the factories where the entire processing process will take place. The cold chain is essential because it prevents decomposition and guarantees the safety of the final product. Once at the factory, trucks unload the raw materials into large stainless steel containers. Everything is handled with strict hygiene and traceability standards, as gelatin is a product that, at the end of the process, will be consumed directly by people of all ages, including children and medical patients. From there, the pretreatment begins. Initial wash. The bones, skin, and cartilage are washed with plenty of hot water to remove traces of blood and fat. Bone crushing. Huge industrial crushers reduce bones to small fragments. This facilitates the penetration of chemical solutions in subsequent stages. Cutting of hides and soft tissues. Mechanical blades cut the hides into thin strips. In this way, the material is prepared for the most important step: collagen extraction. The ground material is immersed in large stainless steel tanks filled with carefully controlled chemical solutions. This process, known as hydrolysis, can last several days. Its purpose is to break down the long collagen fibers into smaller, soluble fragments. Hydrolysis can be carried out in two ways: acid hydrolysis, mainly used for pig skins. Mild acids are used, which act for 1 or 2 days. Alkaline hydrolysis, used primarily for bones and cow hides. It can take weeks as the material is harder. The result is a viscous mixture, not very pleasant to look at, but loaded with soluble proteins. This is, in essence, the heart of the future gelatin. This mixture is then transferred to controlled cooking tanks, where it is heated to temperatures approaching 100 degrees Celsius. With the heat, the collagen fibers transform into a thick, translucent liquid, the pure basis of gelatin. Even though it already has a gelatinous base, the liquid still contains unwanted residues, solid particles, fats, minerals, and excess water. To solve this, the mixture goes through several stages. Filtration: precision industrial filters remove microscopic impurities without altering the parent protein. Vacuum evaporation: the mixture is introduced into chambers where the pressure is reduced. This causes the water to evaporate at lower temperatures, preventing the protein from degrading. At the end, the resulting gelatin concentrate is much purer, more consistent and free of contaminants. This substance is the base to which flavors and colors are later added. The flavoring and coloring phase is crucial because it is here that the flavor, aroma, and visual appearance that distinguish each type of gelatin on the market are defined. To achieve this, enormous industrial mixers are used in which the concentrated, purified gelatin is combined with various ingredients dosed with millimeter precision. These include flavorings which can be natural, obtained from fruit and plant extracts, or artificial, designed to replicate recognized flavors and maintain consistent consistency batch after batch. The most common flavors include strawberry, lemon, pineapple, cherry, orange, raspberry, and grape, although the possible combinations are practically endless, from tropical flavors to special blends for customized products. Sugar is also added at this stage, whose function is not limited to sweetening alone. It defines the final product profile, balances the natural acidity of certain flavors, and helps enhance the intensity of the chosen aroma. Along with the sugar, small amounts of approved food preservatives are added, whose purpose is to ensure that the gelatin retains its freshness for weeks or even months, without altering its flavor or characteristic texture. Next comes the coloring, which gives the product its visual identity. Depending on the intended use and type of gelatin, these can be natural, such as pigments extracted from vegetables, fruits or spices, or synthetic, produced in laboratories to achieve brighter, more stable hues that are resistant to the passage of time and light exposure. The goal is for each gelatin to present a uniform, attractive and recognizable color, reinforcing the association with its flavor: the intense red of a strawberry, the bright yellow of a lemon, the green of an apple, or the characteristic purple of a grape. Once all the ingredients are added, powerful industrial agitators go into action, mixing the gelatinous base with the additives until a completely homogeneous texture is achieved. This process is essential to prevent the formation of lumps or areas with uneven concentrations of flavor or color. The result is a smooth, vibrant and aromatic mass that now resembles much more the gelatin that consumers recognize. At this point, gelatin is no longer just a translucent, tasteless substance, but acquires the colorful appearance, sweet aroma, and characteristic flavor that have made it a universally recognized and enjoyed product in multiple forms. In this phase of the process, the prepared gelatin mix is transferred to high-speed dosing machines designed to precisely fill thousands of molds per minute without waste or errors. These molds vary depending on the final product, ranging from individual cups ready for direct consumption, large blocks that are later divided into portions, fun shapes for colorful gummies, or thin sheets used in industrial baking applications. Once filled, the molds advance on conveyor belts towards specially designed cooling tunnels that maintain a constant low temperature, allowing the gelatin to solidify gradually, thus preserving its characteristic firm yet elastic texture. This gradual cooling is essential to prevent the product from losing quality, as a sudden drop in temperature could affect its consistency or cause surface defects. The time spent in the tunnels depends on both the format and the size of the portion, ranging from about 20 minutes for small pieces to more than an hour for large pieces for larger blocks, so that each presentation reaches the next step of the process with the exact firmness that distinguishes it as a perfectly achieved gelatin. Once the gelatin has reached the necessary firmness, demolding and cutting begin, tasks performed using automated systems designed to preserve the product's integrity. Individual portions are precisely extracted by robotic arms that prevent breakage, while the large sheets are subjected to calibrated industrial blades to divide them into cubes, strips or sheets, depending on the format required for their final destination. Once this step is completed, quality control begins, considered one of the most critical phases as it determines which products will advance to packaging. High-definition cameras and optical sensors continuously check for uniformity of shape and color, while specialized technicians evaluate aspects such as texture, flavor, and the characteristic trembling that distinguishes a perfect gelatin through direct testing. Any batch showing irregularities is immediately removed for reprocessing or discard, ensuring that only units that meet the highest quality and safety standards continue on to the final stage of packaging and distribution. In the final stage of the process, the finished gelatin is transferred to the automatic packaging line, where high-speed machines place it in different presentations depending on the commercial destination, whether individual cups, family-sized trays, or industrial packaging for large consumers. Once placed in their containers, the units are hermetically sealed with lids or special plastic films that ensure protection from air, moisture, and potential contaminants, ensuring the product maintains its freshness and quality for longer. Each container then passes through an automatic labeling system that prints and displays key information for the consumer and batch traceability: flavor, production date, expiration date, batch number, and a code that allows tracking throughout the entire manufacturing process. Once packaging and labeling are complete, the gelatins are neatly grouped into cardboard boxes, which are then stacked on standardized pallets to facilitate logistics, and finally loaded into refrigerated trucks equipped to maintain the optimal temperature during transport. From there, distribution extends to a wide variety of destinations, including supermarkets, hospitals, schools, institutional cafeterias, and retail stores around the world, allowing a product that began as a byproduct of the meat industry to reach millions of consumers in the form of a sweet, appealing, and safe dessert. What begins as bones, skin, and cartilage ends up transformed into millions of sweet, colorful portions with a unique texture that are consumed around the world. Gelatin represents a clear example of how science and industry can take advantage of what seems like simple waste and turn it into a versatile, safe, and valuable food, present in both desserts and medical and industrial applications. The next time you see gelatin vibrating on your plate, you'll inevitably remember that behind its apparent simplicity lies a complex industrial process that combines chemistry, biology, engineering, and strict quality controls to ensure that each portion retains the firmness, shine, and appeal that have made it one of the most recognized and enjoyed products worldwide.